Soil is a vital part of the natural environment. It is a prerequisite for having plants, animals, rocks, rivers and humans, and forms an important part of the biosphere. It influences the distribution of plant species and provides a habitat for a wide range of organisms. Soil is in danger in many parts of the world due to urbanization, deforestation, poor agricultural practices, overgrazing, and municipal waste, leaving it degraded and unproductive. Soil quality is very important, as good quality soil provides nutrients in adequate amounts and in proper balance for the growth of crops and plants. Loss of organic matter is one of the main causes of soil degradation and decreased water retention capacity. Chemical fertilizers and pesticides impact soil composition, humus content, and pollute the groundwater. In addition, long-term usage of pesticides affects human health and the environment. Organic fertilizer offers a very good solution to enrich the organic content of degraded soil. It provides greater stability than mineral fertilizers as it feeds the humus and improves soil productivity. Furthermore, it does not wash out easily, as it offers greater resilience to extreme climatic events. Kitchen scraps, garden waste or animal manure are some of the sources of organic matter. Compared to chemical fertilizers, fertilizers with high organic content take much longer to break down. The lengthening of this process helps the nutrients last longer and be delivered at an optimum rate, ensuring that plants are constantly nourished. The production of organic compost mainly depends on the good quality of organic waste derived from households and commercial farms. People often dispose of waste without proper segregation at the source, making it less viable for recycling or producing good quality compost. Therefore, the first step is to separate waste at the source, as it enables the recovery of biowaste from kitchens and gardens. As the organic matter decomposes over time, its storage should be as short as possible. For efficient utilization of biowaste, it is necessary to consider that biowaste can contain numerous plant pests that require sanitization. In this process, the waste is heated up to 70 degrees Celsius for a few hours. There are various methods to treat biowaste, and some of them are composting and biogas plants. Composting is the biological decomposition of separately collected biowaste by microorganisms in the presence of oxygen and under controlled conditions. Through this process, compost is produced, which can be used as a soil conditioner in agriculture. As the metabolic rate of the microbes accelerates, the temperature within the system increases. Composting can be centralized or decentralized. Centralized composting can be undertaken in open heaps that are turned and mixed mechanically in windrows. Composting can also be undertaken at a much smaller, decentralized scale, and has been a traditional practice among home gardeners. Another treatment method is in the biogas plant, where organic waste is fed into a sealed tank called a digester, where it is heated and mixed. In the absence of oxygen, anaerobic bacteria consume the organic matter to multiply and produce biogas. Waste coming out of the digester can be separated into solid and liquid. The solid part can be composted, and the liquid part can serve as fertilizer. Waste should no longer be considered as waste. Resources can be recovered by efficient management practices, involving waste prevention, improved separation, recycling, and material recovery, forming a closed-loop system and thereby supporting sustainable living.